Dear students, welcome to my channel HSC English version DD. Our today's topic is when to use which formula to solve river board problems. But before learning the applying tricks of river board problems, we need to know about some basic informations. Look at this video first. This river is very calm and there is no flow of water current here. Flow of water current is a vector because it has both direction and magnitude of its own. We know that to get a resultant, two vectors are needed. To solve river board problems, we have to have two vectors. One vector is the water current and the other vector is the velocity of boat. As in this type of rivers, we get only one vector and that is the velocity of boat. Therefore, this type of rivers are useless to determine river boat problems. Now, look at this video. This river is very turbulent and there is a strong flow of water current here. See, direction of the boat is changing due to the water current. The boatman is struggling enough to handle the boat. As in this type of rivers, we get the vector water current along with the vector velocity of boat at a time. That's why this type of rivers are used to solve riverboat problems. Now look at this picture. Think this river as a turbulent river and this is the direction of the flow of water current. We can shift this vector from here to here like this. Suppose this boatman wants to reach here in this B point straightly from this A point by rowing his boat. Will the flow of this water current allow him to reach straightly along this AB way? Of course not. This water current will push the boat continuously towards this direction. At the same time, velocity of this boat will try to take the boat towards this direction. As a result, the boat will fall into a tug. Neither the boat will go in this way nor in this way. Actually, the boat will go in this way slowly like this. This way is called resultant. This is the resultant that will be the new direction for this boat. Let this situation as case 1. Now think the boatman wants to row his boat against the flow of this water current like this so that he can reach at this B point by using push force of this flow of water current like this. Therefore, this AB way will be the resultant and this resultant will be the new direction for this boat. Let this situation as case 2. We denote the velocity of boat as V, the velocity of water current as U, the width of the river as a small d, the resultant as W. That means U, V, W. If we would write here P instead of this U and Q instead of this V, then we would write here R instead of this W, so that we could say PQR. Look at this case 1. This is a vector. This is another vector. We know that if two vectors spread from one common point at a time, then we get a resultant. Therefore, for these two vectors, this is the resultant. Again, we know that the angle between two vectors is called alpha. So, in this case, this angle is alpha. Look at the case 2. This is a vector and this is another vector. This is the resultant for these two vectors and this angle is alpha. Now we will learn when to use which formula to solve river boat problems. Generally, we get three categories of questions on river boat problems in the exam. Questions on determining distance, questions on determining time, and questions on determining the value of resultant. Again, determining distance can be of three types: minimum distance, distance along bank, and other distances. And also determining time can be of two types: minimum time and other times. Now we will learn which formula should we apply to determine minimum distance, distance along bank, other distances, minimum time, other times, and the value of the resultant with full of explanation one by one. The first one is minimum distance. Minimum distance means from here to here. See, these paths cannot be the minimum distance because these paths are comparatively greater than this path. Do remember, in the question paper, instead of minimum distance, you may get the words straightly or vertically or at a distance along with or towards the opposite bank or along the shortest path. The meaning of all these words are the same. We can solve this type of math in different ways by applying different formulas. But among them, the easiest formula is tan theta equals v sin alpha over u plus v cos alpha. Actually, to cross the river at minimum distance, the boatman should row his boat at an alpha angle with the respect of the velocity of water current. See, in this formula, alpha is present. Here, the value of theta will always be 90 degree. We will get the value of u and v from the question. By using all the given data, we can easily get the value of alpha. So, for this problem, we will always try to apply this formula. Look at this stimulus now. The current velocity of a river is 2 km per hour. Boatman Kamal wants to reach on the other bank of the river at a minimum distance. The velocity of the boat is 4 km per hour. The width of the river is 2 km. The question is, at which direction Kamal should row his boat? See, we are asked to determine the direction. We know that at physics, to find out the direction means to find out the angle. That means we will have to find out the value of alpha here. We also know that alpha is the mid angle of two vectors. Now listen carefully. In this case 1, this is the angle alpha and this angle is the mid angle of these two vectors. And in this case 2, this is the angle alpha and this angle is also the mid angle of these two vectors. Now the question is, between these two alpha, which alpha will be our required alpha? For this case 1, the boatman is trying to cross the river along this minimum distance. When the boat is supposed to reach here in this point, the velocity of water current pushes the boat here in this point. When the boat is supposed to reach here in this point, the velocity of water current pushes the boat here in this point. And again, when the boat is supposed to reach here in this point, the velocity of water current pushes the boat here in this point. As a result, at last the boatman reaches here. This distance cannot be the minimum distance. Therefore, if Kamal starts rowing his boat along this path, he will never cross this river at minimum distance. So, this case 1 will be of no use to us. For this case too, the boatman is trying to cross the river along this way. When the boat is supposed to reach here in this point, the velocity of water current pushes the boat here in this point. When the boat is supposed to reach here in this point, the velocity of water current pushes the boat here in this point. And again, when the boat is supposed to reach here in this point, the velocity of water current pushes the boat here in this point. As a result, the boatman at last reaches here in this point, and this way of distance is the minimum distance. Therefore, if Kamal starts rowing his boat along this way, he will be able to cross the river at a minimum distance. We will have to determine the value of this alpha. The angle between this resultant and this velocity of water current is called theta. The value of this theta is 90 degree, as this is a right angle. If we put the value of u equals 2 km per hour, v equals 4 km per hour, and theta equals 90 degree here, then we get tan 90 degree equals v sin alpha over u plus v cos alpha. We know that the value of tan 90 degree is undefined. We also know that something over 0 equals undefined. So we can write 1 over 0 instead of this tan 90 degree equals v sin alpha over u plus v cos alpha, or u plus v cos alpha equals 0, or v cos alpha equals minus u, or cos alpha equals minus u over v, or alpha equals cos inverse minus u over v, or alpha equals cos inverse minus 2 over 4, as u equals 2 and v equals 4. Therefore, alpha equals 120 degree. That means Kamal should row his boat at an angle of 120 degree with the respect of current velocity. Now we will learn which formula should we apply to determine the distance along bank. Look at this question. The current velocity of a river is 2 km per hour. The velocity of the boat is 4 km per hour. The width of the river is 2 km. Determine the distance along bank. Here we are asked to determine this x distance. For this type of math, we will always apply only one formula, and that is x equals u plus v cos alpha times d over v sin alpha. See, here velocity of water current u equals 2 km per hour, velocity of boat v equals 4 km per hour, distance d equals 2 km, and alpha equals this 90 degree. So we can write x equals 2 plus 4 cos 90 degree times 2 over 4 sin 90 degree, or x equals 2 plus 4 times 0, as cos 90 degree equals 0, times 2 over 4 times 1, as sin 90 degree equals 1, or x equals 1 kilometer. This 1 kilometer is the distance along bank, and this is our answer. Now we will learn which formula should we apply to determine other distances. Look at this question. Find the distance traveled by the boat along AC. Here we are asked to determine this distance. As the value of theta and side is given here, therefore for this type of math we will always use trigonometric formula. Do remember, if we have the value of theta and we are asked to determine the value of side, and again if we have the value of side and we are asked to determine the value of the angle theta, then closing our eyes we will apply trigonometric formula. That means sin theta equals opposite over hypotenuse, cos theta equals adjacent over hypotenuse, and tan theta equals opposite over adjacent. See, this is a right triangle. This angle is a 90-degree angle. This angle is theta. Opposite side of the theta angle is called opposite. See, this side is opposite to this theta angle. So, this is opposite. The side which is next to the theta angle is called adjacent. See, this side is next to this theta angle. So, this side is adjacent. Opposite side of the right angle is called hypotenuse. See, this side is the opposite side of this right angle. So, this is hypotenuse. Now, look at the question. This is a right angle. This is adjacent as this side is next to this angle. This is a right angle. This side is the opposite of this right angle. So, this side is hypotenuse. For the presence of angle and sides, we can easily apply here trigonometric formula. But question is, among these three formulas, which formula should we apply here? As the value of the adjacent and theta is given here and we are asked to find out the value of hypotenuse, therefore we will apply this formula. Cos theta equals adjacent over hypotenuse. Here theta equals 60 degree, adjacent AB equals 1.5 kilometer, hypotenuse AC equals what? So we can write cos 60 degree equals AB over AC, or cos 60 degree equals 1.5 over AC, or AC equals 1.5 over cos 60 degree. Therefore AC equals 3 kilometer. This is our answer. Now we will learn which formula should we apply to determine this minimum time and these other times to cross a river. For these two types of problems, we will have to apply only one formula, and that is time t equals distance d over v sin alpha. Do remember, we may not get the value of alpha in the stem. If so, then we will have to determine the value of alpha first, and then we will solve the math with this formula. Look at this question. Find out the necessary time to cross the river. See, we are not asked to determine the minimum time here. Distance d is here 2 km. Velocity of boat v is here 4 km per hour. And the value of alpha is 120 degree here. Just a little while ago we have got this value. If we put the value of d, v and alpha in this formula, then we get time t equals 2 over 4 sin 120 degree. Therefore, t equals 0.5774 hour, and this is the answer for this normal case. Now look at the question again. Determine the minimum time to cross the river. According to the question, if we want to find out the minimum time, then the boatman Kamal must row his boat along this minimum distance. Though he will not reach here in this point. He will reach here somewhere. Suppose he will reach here in this C point. This new direction is called resultant. For this way, the velocity of the boat will be v. This is the velocity of water current u. See, this portion of case 2 and the picture of case 1 are the same. So, avoiding this complex picture, we will use this picture to solve this math. This is a vector. This is also a vector. Between these two vectors, this angle is alpha. Now look at this formula. We are asked to find out the minimum value of this time t here. Therefore, if t is to be minimum, then sin alpha must have to be maximum. Do you know what is the maximum value of sin alpha? Yes, the maximum value of sin alpha is 1. So we can write sin alpha equals 1 or alpha equals sin inverse 1. Therefore, alpha equals 90 degree. If we put the value of d, v and this alpha here in this formula, we will get t equals 2 over 4 sin 90 degree or t equals 2 over 4 times 1 as sin 90 degree equals 1. Therefore, t equals 0.5 hour. This is the answer. Now, we will learn which formula should we apply for determining the value of resultant. Look at this question. The current velocity of a river is 2 km per hour. The velocity of the boat is 4 km per hour. Determine the velocity of the boat to reach the other side of the river. Here, we are asked to determine the value of this resultant. For this type of math, we will apply resultant W equals square root u square plus v square plus 2uv cos alpha. See, here the current velocity of river u is 2 km per hour. The velocity of the boat v is 4 km per hour. The angle between two vectors alpha equals 120 degree. Just a little while ago we have got this value. If we put the value of u, v and alpha here in this formula, then we will get w equals square root 2 square plus 4 square plus 2 times 2 times 4 cos 120 degree. Therefore, W equals 3.46 km per hour. That means the boat will reach the opposite side at 3.46 km per hour with resultant velocity. And this is our answer. Thanks a lot for watching this tutorial.